All right, so we got two systems right now that are sort of in the works. That one's actually probably 99% done. Few little odds and ends. I'm just going to clean it up. That one's ready to go. This one, all the piping's done and pressed. All that this needs is the wiring for the circulators and the temperature sensors. We are actually in the process now of starting a third system. This one is actually going to be a little bit more fun, I guess, as you could say. This one's actually going to implement a radiant heat zone and a baseboard zone. So what we're going to end up doing is using a mixing valve for this system in order to provide a lower temperature for the in-floor baseboard. So right now what I'm doing is actually I just got a lot of my parts in. So what I'm doing, first thing I do is basically take inventory of all the parts I ordered that I sort of designed the system to need. And then I sort of get everything ready here on my bench. Everything that's going to need fittings and adapters screwed in, I get all that stuff placed here on the bench. It's kind of become, almost muscle memory knowing what things to place over here. I mean, some of it's pretty obvious. If it has threads, it needs threads. But basically what I mean by that is I have it sort of down to a science where unpack my parts. I know immediately if something's missing, just kind of by feel, as I'm taking things out of the box, you're just sort of thinking I should have one of these, two of those, things like that. So then I'll start setting my adapters up here and lining them up as I go through boxes. And then I start getting into the process of what I like to do is get all that stuff out of the way. I've shown in other videos basically me doing this and how I go about it and what I use. I use a combination of some tape and pipe dope, and I use it in a specific combination. I do a little bit of the pipe dope, a little bit of tape, and then back to the pipe dope. It makes a 100% leak-free fitting every single time. I've literally never had one fitting leak on me. So basically, like I said, I'm just going through the boxes, organizing everything, and then once we basically take inventory, make sure we have everything, sometimes they mess up a part, they miss a part here and there. It is what it is. I either run to the local supplier or I just order it again if I still have some time to kill. And then we'll start laying things out. So what I actually also did was went ahead and paint this. So I always paint, I sort of call this my boiler canvas. I usually get a sheet of plywood. I actually pick the type of plywood or the type of panel to be used dependent on what I recommend to the customer. Maybe customer has a preference, whether they want sort of a full waterproof panel, a plywood panel, whatever it may be. So with this one, I actually used a 3/4 piece of plywood and painted it with a black deck paint, which I've found to be extremely durable. It's completely scratch resistant. I mean, I'm climbing all over these boards. Sounds kind of silly, but basically when I'm building it, I'm literally stepping all over this thing. And when I'm done, there's not a mark on it. This one over here has a little bit of dust laying on it, but literally I was trampling all over this, setting everything up, and there's not a footprint, nothing. So extremely durable paint. It'll hold up to any condition, even in a basement or anything like that. And obviously because it's built for decks and rain and winter and snow, it's really durable for holding up to all the elements, and especially anything you'd find in even a damp basement. I don't recommend using pressure treated plywood, even if you are going in a damp environment, because you really don't want those chemicals that bolted, the boiler is bolted right to that wood, leaching into the boiler, maybe corroding some of it. Those are really aggressive chemicals that are in that pressure treated plywood. So you're always better off mounting it on a piece of normal plywood and actually just offsetting it. At most, what I would possibly do is just use some pressure treated 2x4s, whether it's bolted to a foundation block or even old homes where it's a cobblestone and in a basement like that, just bolt some pressure treated 2x4s and then mount the panel to the 2x4s and it'll be good to go. So basically, yeah, I'm just getting that panel's just painted, ready to dry. So by tomorrow, this stuff's dry enough to be able to start mounting the boiler on it by tomorrow. And it just continually gets harder as the days go by. So yeah, I'm just going to keep going through these boxes, and I'll kind of come back in and show you guys the next part as I start assembling things. Okay, so now that I've gone through and sort of collected all my parts and pieces, I actually am just missing one of these 1.25" Pro Press to thread adapters. So just ordered one more of those. I did order two, but they forgot one. It happens almost with every order, to be honest. I missed something, but I'm ordering a ton of stuff. I'm sure it's people throwing all these random things in a box, and sometimes you'll get an extra part you didn't order. I guess overall it evens out, and it only takes 2 days for them to ship it. But like I said, at worst case, I could run to my local supplier and pick anything up like that. So basically what I'm going to start doing is assembling any of the adapters onto any of the pieces and parts that need them. And what I also do is actually go through and separate any of the items that are going to get screwed directly onto the boiler. So I also do that in a separate stage. So a lot of these service valves here, I'll go ahead and take off the unions here, pull the O-rings out, and I'll walk these pieces all over to the boiler and get them all set up. So then I basically sit right down at the boiler and assemble all those at once. So I know everything that goes onto the boiler is assembled, completed, and finished. Then I come back over here, assemble all my pieces, and just start the process of getting everything installed in order. Also, what I do is I actually come up with a sort of little sketch for my own. It's all in my head, basically, but I like to do this since I'm dealing with a lot of systems at once. You know, I don't want to confuse one from the other. So I always make sort of little sketch, and I take the parts that I received and I bring them over here, and I kind of just play around them on the floor to make sure that my design matches up with the pieces. So for this one, like I said, we're going to be incorporating a baseboard zone, which is this right here. These are my little sketches for the pump. This is the return. This is going to be for the in-floor zone. So here is the pump for the in-floor zone, and this is going to be a mixing valve. And here's the return. So this is sort of how it needs to get piped. I always just do like a diagram view, a top view for myself, and then sort of, I guess you'd call it a 3D drawing. It's pretty bad, but it really does help when I'm trying to get these things together. So basically I just laid out my pieces and parts. The only thing I am missing right here is the mixing valve. That's actually going to arrive tomorrow, but I'm confident I have all the T's and elbows I need. And also, you may not be able to tell on camera, but these are specific sizes that I order, special to work with the flow rates and everything that I designed this to. So depending on the total flow rate and how much you're delivering to all of the zones, you're going to want to be a certain size to be able to flow that amount of gallons per minute. Then each zone requires a specific gallon per minute to deliver out however many BTUs I've calculated there to need. So for this one, it's actually the 1.25 inch that's going to be feeding a 3/4 and a 1 inch. So the 3/4 is going to be for the baseboard zone. It is one loop of baseboards, and the 1 inch is going to be going to the in-floor zone, which leads to a radiant loop manifold that has multiple 1/2 inch loops on it. So I've ran all the calculations. I've figured out my pump sizes. I figured out how much gallons per minute there needs to be. So that's how I go ahead and lay out my piping. So this T right here is actually 1.25 inch to 3/4 to 1 inch. It's really cool that you could buy things like this. They aren't cheap, but I'll tell you what, it's really nice instead of having to buy multiple adapters or just running 1.25 inch for the whole thing. So, you know, you can never go too big in pipe size. I mean, there is a point where it would be too large. But I mean, nothing in these systems really. If I ran 1.25 inch all the way to the baseboard zone and then just put a 3/4 adapter at the right before it goes in the baseboard, I mean, it's excessive, it's expensive. So even though I'm spending a little bit more on the fitting, I'm saving a lot of extra material you don't necessarily need all the way up to the pump and whatnot. So this will all start making sense as I start laying it out on the board here, but that's sort of the steps I take as leading up to starting to mount all this stuff together. So what I'm going to do right now is actually separate all the pieces that need to be connected directly to the boiler versus the parts that need to just have fittings. We're going to actually get all of the components that need to be attached directly to the boiler. What I did earlier was separate all of the threaded parts that came off of some of the components like the service valves and some of the shutoffs, and the backflow preventer, things like that. I separated all of the threaded fittings that need to go right onto the boiler. So what I do is I sort of situate the boiler in the approximate location on the board that I want it to lay out. It really doesn't matter right now because all we're doing is fastening these components to it. So I like to lay a blanket down to protect the plywood so I don't get any of my pipe dope on it or scratch up the board, which, like I said earlier, this stuff is really hardy. It's mostly just to keep pipe dope off from getting stuck all over the plywood if I drop any. So what we're going to be doing is mounting the service valves, the hot and cold domestic service valves, the backflow preventer, and I think that's about it. And then also on the top of the boiler, there's actually the air bleeder that comes with the Navien unit, so that'll get screwed into the top. And then we will mount the stainless steel manifold that's sold by Navien. I use this pretty much on every single system I do, unless I have a space constraint, or if we're going to be using something like a storage tank or whatever it may be. It really depends on the design, but if it's a straightforward system like this, I use this 99% of the time. So we're going to go ahead and get everything mounted on here, and then we can move forward with mounting the boiler and figuring out how much space I need on this board to lay out my zones. So sometimes we'll have the zones on the left side, sometimes on the right, sometimes we'll have just the supply zone for the zones on the left, the return on the right. We can make them in any configuration possible. Some of that has to do with limited space constraints some people have. I'm a big fan of not taking up an entire wall if you don't need to. So a lot of HVAC installers or boiler installers will go in and, you give them a 10-foot wall, they're going to use it. There are some, rules you need to follow with minimum distances before, before elbows and certain components. That gets into a little bit more detailed design stuff that I do explain a little bit in other videos, so go ahead and check those out. But essentially, I like to make these as compact as possible, but still following the rules, the basic rules of hydronic boiler design. So we're going to go ahead and get all these components on and move on to the next part. So now I've grabbed all my fittings that need to be assembled directly onto the boiler. So basically, I got these all laid out and everything necessary. There's some rubber plugs on here that come when they're the items are shipped. So you just go ahead and pull all the necessary ones off. I'm going to go ahead and put some pipe dope and tape around all of these and get all my fittings on here. And I do them in an order, basically bottom to top, so that I could actually, get the two valves on, tighten them from the bottom, work my way up so I'm not in the way, because it is very compact in here. They obviously try to make these boilers very compact, so that means a lot of the valves end up being very close together, but I've figured out an orientation that works really good as far as which direction to point everything. Basically just came with experience of doing these and what worked best. So I'll go ahead and start getting these on here. Now that I have all my fittings attached to the boiler, now I could go ahead and start installing the service valves for the heating portion and the domestic hot water, as well as the backflow preventer, and we'll get going on those, and then we'll install the manifold onto the heating service valves. Okay, so now that we have all of our components connected to the boiler, such as all the shutoffs and the manifold, what we're going to do next is actually situate the boiler on the board where we want it to be. I'm actually going to shift everything and start over all the way on the left, and this system is actually going to be, supplies and returns will be on the right side of the boiler. I can configure these any way possible. Everything over on the left, everything on the right, some supply on the left, returns on the right, but this customer would like everything over on the right side of this of the boiler. So what I do is actually sort of situate the boiler where I want it. And then I'll start laying out my parts and pieces, all the other components that are going to go along with it, just so I could get a visual of how much of the panel we're going to take up here. I pretty much have set distances away from, for instance, if I put my pumps a minimum distance away from the boiler, and then I will put the return piping a minimum distance away from that, so that way you have enough room for maintenance to get in there to change out a pump, or even when you're servicing or flushing out the system, you have good access to everything. But at the same time, I like to still make these as compact as possible. I did mention there's minimum distances to some of these components, so I also need to be aware of that when I'm building. And that just kind of all goes into the design. It depends on the diameter of the piping and how I calculate minimum distances to specific components. So I have everything laid out here, so this just gives me a good visual, like I said, everything I need to do before I start actually cutting copper piping and fitting everything together. So with this sort of figured out in my head here how I want it, I'm going to go ahead and actually mount the boiler and actually get that screwed down to the plywood all the way over on the left side. And then we'll relay out our pieces again and actually start connecting each component with some copper pipe. I don't actually get everything, I sort of get all the piping figured out, all the lengths, then I prep all of the copper pipes, then I'll assemble everything back again, and I'll actually start mounting everything with brackets down to the plywood. Once everything is completely figured out and situated and piped together, that's when I'll start actually using the pipe clamps to attach everything down to the board. Then I will go and press all the fittings. So that way I have everything completely figured out before I press any fittings. I don't press as I go, because sometimes you do want to make adjustments. Something doesn't look right. You want a little more spacing between something. Maybe you forget something. I mean, all those things, I really wait till everything's completely laid out. And I have the benefit of being able to do that when you're in a shop environment like this. You know, if you're in a tight area in a basement, sometimes you just got to build it as you go. But I have the benefit to take my time and lay everything out correctly. So that's the way I approach it. So like I said, I'm going to get this boiler screwed down here, and we'll start cutting some copper pipes and fitting everything together. So I have my bracket laid out here in the position that I'm going to need it to get the boiler at the correct height and placement on the board. So we're going to go ahead and lag in some bolts right into this bracket. And now with the top bracket installed and the boiler hanging on that top bracket, just give it a tug down here, make sure it's really settled in, and we'll just go ahead and place a few bolts down at the bottom here to really get this boiler mounted down. So now that the boiler is completely mounted and anchored to the plywood board, we can start mounting all our components and cutting the copper pipes and getting this thing all laid out. Okay, so once I lay out all my components once again and sort of get my bearings straight of how I want everything laid out, I'll go ahead and start cutting some pieces to get everything sort of mocked together. So what I'll start with is basically we're going to have the supply portion come up and bend up this way and kick over, and the returns will sweep back into the bottom of the manifold here. So I could basically build the returns first, because that's going to be my lower level, if you will, of piping, and the upper level will be the supplies that are kicking and coming back in this direction. So with my first piece that I'm going to be using here cut, what you'll see me doing with all of my pieces that I cut, once I use the pipe cutter, you know, what it does is leave this indentation around where the cutting wheel put a groove into the pipe. So anytime you're cutting copper pipe with like that, you're going to use a reamer to clean that stuff out. So the reamer that I use is this drill attachment. It's a REMS REG 1054E. I did a quick review video on it, so go ahead and check that one out. But basically, I just go into what product it is, how it works. So basically, just you could it'll do either the outer portion of the pipe or the inner. So for this one, I'm more concerned with the inner because it's been damaged by the pipe cutter. So you could see that the pipe would just go right into here. I put the drill on the lowest speed setting, and instead of doing this by hand, which you could certainly do, that's why it has these grips here, it's nice to just put on the drill and just put over a garbage can here so all the copper drops out. And I'll go ahead and do both sides. And what you'll see is that there's a nice indentation rather than a piece of lip over that. So that makes all the piping really clean. That way any water going through there won't build up any turbulence and start corroding away at that. And that's really the best way to go about it. So at this point I have the majority of the main piping laid out and just sort of loosely fitted together. So at this point what I go ahead and start doing is putting in some of my pipe support clamps, and what that'll do is actually get everything sort of at a base level of how I want the height of the returns, and then I sort of build everything off of that. So I'm going to go ahead and cut some of this threaded rod here, get some sealing plates together that'll bolt down to the board, and then some pipe clamps of the matching size of pipe here to get everything held together. And I actually cut my threaded rod here with this Milwaukee threaded rod cutter. It's an awesome tool. I did a quick review on it in another video, so again, go check that out if you haven't seen it yet. This thing, I won't go into too much detail, but basically it makes super easy cutting this threaded rod instead of either using a Sawzall or a bandsaw or however you may be doing it, and then the end gets all junked up. So this thing has a set of dies in here that you slip it in, and you just pull the trigger and it slices it perfect every time, so a nut just goes directly on it and you don't have to clean up any threads. So I'm going to go ahead and support this pipe here, get some of those clamps together. So one thing you'll notice I did while I was putting the brackets on and mounting the piping in here is I marked with a black marker on the copper pipe. What that's doing is actually making sure that the copper pipe is inserted all the way in the Pro Press fitting. And once I know it's seated incorrectly, I mark it. So that makes sure that when I get everything mounted together here, I know that that copper pipe is in all the way, because once this gets mounted on here, you know, you're not going to really have a chance to slide things around. So you want to make sure that everything's seated correctly, so when we go to press this, there's no issues with the pipe not being inserted all the way. So that's just a quick little trick to ensure that your pipes are seated properly. And now that we have the return piping bolted to the panel, we're basically going to build everything off of that. So that's sort of our base point. And that, what we'll end up doing is now working on the supply that's going to come up and direct itself back this way. And that'll be a level above this return to allow for the return piping to go underneath the supply, and be able to basically have enough spacing for everything to fit within here and be able to access everything for maintenance, and just give everything a really good visual look as well. This thing will be really pretty when it's done. So at this point, I'm just going to keep building all the piping as I go and get this thing assembled. Alright, so I'm making really good progress on the return and supply piping for the main portion of this build. So what we'll end up doing next is actually building off the pumps and the return valves right there, and basically do the same thing. We'll mount brackets to everything, and that'll finish up all the main piping. As you can see, I kind of just went methodically along and cut all my pieces as I went, added my brackets as I went. Surprisingly, without even any of this stuff pressed, obviously yet, it's very, very sturdy. I mean, some of these pieces won't move at all. Obviously, there is some play because these are not pressed. However, when you do go to press this, it's amazing how strong that it actually is all together. So between the brackets and the press fittings, it's really solid. So we got the pumps installed and all the piping configured and bolted on with the brackets. So that finishes up the supply end of it. As you can see, I use the standard brackets that we've been using during this whole thing. And then actually what I do here is use a sort of conduit clamp that fits perfectly over the PEX fitting and doesn't interfere where the PEX will connect to there. So I kind of came up with that configuration after a little bit of trial and error building these systems, so that works really well. So all that's left really is to finish up the return piping and the brackets for that. That'll only need one bracket on the piping here, and that'll keep it really sturdy. And then we'll be able to basically go ahead and press all these fittings. So I'm going to go ahead and finish up this return piping now, and we'll move on to the next step. So at this point we have the returns installed And the service valves for flushing the system, everything's bolted down with the brackets, tightened up as much as it can be. That completes all the piping. So now at this point we're going to get the Pro Press out and start pressing all of these fittings. While we do that, we're going to make sure that we're following all of our black marks and make sure everything is seated correctly. Make sure everything is oriented in the correct position. You really want to take your time. Don't just get in a hurry and start pressing everything. You really want to make sure as you go, again, doing it methodically and taking your time and making sure that all the work we just did doesn't go to waste, because it is a pain if you press something and now you have to cut and fix it. Depends. You could ruin a fitting. If you ended up something like this, you would need to get a new fitting for this mixing valve. So things like that. You just want to take your time, just like everything else during this entire build. So once we get everything pressed here, then we'll move on to the electric. Fittings are pressed. What I basically do next is pressure test the system. You do not need to do this with water. You could just do it with air. I will say I've never had a leak on any of my systems building these this way. Everything from the Pro Press fittings to all of the threaded fittings. It's really important to, especially in the threaded fittings, make sure you do them correct and do them so that you guarantee, without even testing the system, that they're not going to leak. And by doing that doesn't mean just caking on a lot of pipe dope or putting on a ton of tape around the threaded fitting. It's basically just understanding the right and perfect amount to just get it right every time. So I've shown the process of how I do that with the threaded fittings, and again, the importance of pressing the Pro Press fittings, same thing. You just need to be very careful in making sure you're marking all of your pipes and like I said, taking your time, making sure everything's inserted correctly into all the fittings. And if you do that, you're pretty much never going to have any problems. If you kind of try to move quickly, or you skip a step, or you don't mark your pipes, your fittings, I mean, you're definitely going to run into issues, and it's a headache later when you have to, if you were to press a fitting and the pipe's not in enough, it's not just a matter of fixing the fitting. You can't. You're cutting everything out. Now you're screwing up everything, and it kind of dominoes down the line. Just again, I stress to take your time, do it right the first time. So what I'm going to do here is I actually have a pressure gauge hooked up. It's a nice little part right here where it just takes an air gauge, and I just thread that right into the air separator, and it's just got a air chuck fitting on here. So I just go ahead and fill it with some air. I'm just going to go ahead and do that. And I fill it up to, this system will only run anywhere from probably about 12 to 20 psi. So let's just put 20 psi in there. You can see on the gauge I got it right at 20. And basically I'll just let that sit here for a few minutes. I mean, I'm confident that this thing is completely leak free, but we'll let it sit here for a few minutes just to double check. And basically once that's good and confirmed, we'll unhook the gauge and we'll start moving on to the electrical wiring for this system. So in order to prepare for doing the wiring on this system, I just got a couple of our sensors laid out here. I have the wire we'll be using to provide power to the pumps. So I'll walk through a little bit of this. Basically I'm using this MC14 2 wire, which will supply power from the zone wiring on the circuit board to supply power to turn on each of these zone pumps. So that's pretty straightforward there. And I'll go about routing that in a nice configuration. Everyone's a little bit different, just depending on whether the pumps are on the right side, the left side, horizontal, vertical, things like that. So I find a nice tucked away area, keep everything nice, neat, and clean. And you always have to think about as you're wiring that you're not sort of blocking or getting in the way of any of these other parts. Like I said earlier, there's a lot of stuff packed underneath this boiler. So the routing and the wiring matters, making sure that you're not blocking any of these valves from turning. So, you know, the cleaner you could do it, and getting those wires tucked down behind there and everything really makes a big difference for later on maintaining everything. So the sensors that I'll be dealing with actually here are one set of sensors is for each of the circulators. So there's basically, this is a VT2218 circulator, which is a delta T circulator. So how that works is a sensor is placed on the supply piping as well as one on the return piping, and then these sensors are both fed into this pump. And what we'll do is when this pump's actually running, you could set the delta that you want it to run at. So if you would like a 20-degree differential between the supply and the return, you go ahead and program in delta T setting to 20, and it will read the temperature on the supply pipe as well as the temperature coming back in the return, and maintain that motor speed to keep it at a 20-degree delta. So what's really nice about these pumps is that you can really tune in this boiler to get the most efficiency out of it. Now, there's some playing around you could do, and I'll get more into it in other videos specifically about these delta T pumps, but these ModCon boilers, modulating condensing boilers, basically want a large delta T in order to condense the most, which then turns into more efficiency. So the wider the delta you could get coming back to this unit, the better. However, you have to understand that in something like a baseboard system, if you're feeding out, say, 180 degrees and you're coming back at around 160, that's a 20-degree delta. That's pretty standard. So that last baseboard on the loop or on the zone is getting that more about 160-degree temperature. So that changes the BTU output from the first baseboard all the way to the last one. So if you widen that delta, you know, if you had it a 40-degree delta, now that last baseboard on the zone is obviously a lot cooler than the first. So that could start altering the amount of outputs room to room, and that could change how much heat you're supplying to one room versus the other. So it's sort of a balance. You know, you want the efficiency, but a big delta, but you also want the comfort in each room in the house. So there's ways to get around that. Like I said, I'll go into more details. But these are, you know, my choice to go with for pumps. Absolutely. Not every time, but almost. And again, those are details I could sort of get into, whether it's a radiant system or a baseboard. But for this, it's a radiant heat system for the in-floor zone, and the baseboard system, we are using them on both zones. So we'll basically go ahead and wire up these sensors as well. And then the other sensor that I use is actually from Navient itself. It doesn't come with the boiler, so you have to buy it separately. It's a system, it's basically a universal sensor that you could use for the system temperature. When we talk about system temperature, we're talking about the zones here. So there's a primary loop that the boiler is basically supplying the hot heating water and returning back to the boiler, and the system zones here are mixing with that primary. So what I use this sensor for is the boiler itself. If you set it to, say, 180 degrees, it only knows it's outputting 180 degrees. However, when it mixes with the secondary loop here, it doesn't know what temperature is actually going out to your zone. So obviously that temperature is going to drop because you're bringing back cold water and mixing it with the hot water that's being supplied by the boiler. And it can only be so precise. So if you set that to 180, you may actually only be getting 165, 170 returning to your zones. And the way to get around that is basically installing this sensor on the system supply, not on the primary loop, but on the secondary loop, feeding all the zones. And then you'll go into the settings and basically set the boiler to look at this temperature. When you set it to 180, it's going to make sure this boiler's firing, which to supply 180 degree water at this. So what that means is the boiler may actually have to create even hotter water so that it's providing. But that way you could accurately fully understand and make sure that your temperature you really want out to your zones to be set for that. This zone, of course, or this system's a little bit different as well because we're dealing with a baseboard zone, which is going to be at about 180 degrees supply temperature. However, the in-floor only needs about 125 degree max. So what we did is incorporate the mixing valve, which basically will supply that 180 degree water to the hot portion side of the mixing valve, and some of that return water coming back from the in-floor will be able to either return back to the boiler to be reheated, and some of that cooler water can actually come into the other side of the mixing valve in the cold portion. These two will be able to mix and supply that temperature that whatever we set this mixing valve to. So we're going to keep this set to about, it's factory set at I think 115, 120, so it may actually be fine to just leave it there, but no more than 125 going in the radiant in-floor. So this is pretty much just going to continually mix the hot and the cool return water to maintain that temperature, even though we're supplying 180 degrees. So that's how you basically are able to separate two different temperatures with one output temperature. So we're going to get into some of this wiring, get the sensors all installed, as well as the power wiring ran to the circulators, get it all nice and cleaned up, and that'll complete all the electrical wiring for the system. Basically wraps up this entire build. Now that all the sensors are installed and wired back to the circuit board, the next thing I've actually done is wrap all of the sensors in this self-healing silicone tape. So I do that for a few reasons. One, basically keeps it a little more secure because they are only held on by the zip ties and the manufacturer supplies, which does a good job, but you know, if someone was to come in here and reach your hand and bump it around, there's a chance it could slide out or pop out. So I always wrap this tape around to really secure it in there. And then also it actually gives it a little bit of an insulating factor now that it's really snugged up against here. It's not meant to be insulating tape by any means, but it obviously will retain the heat a little better wrapped around that sensor. So like I said, that pretty much wraps up this build. The only thing that's missing on here is the expansion tank and the shutoff valve for the expansion tank. So for this situation, the customer is going to slide this in the back of a pickup truck, so we won't be able to put the tank on. I'll supply that to them loose, and they will go ahead and install that on there, as well as do obviously all the plumbing that's required, and that's pretty much it. So I hope you guys liked following me on this build and this tutorial going through this. If you have any questions along the way, if you want me to build you a system, or if you want some consulting and to build your own system, I do designs, I do piping diagrams, parts list, anything you need. So again, if you've liked this video, please give it a thumbs up, and if you haven't yet, please subscribe, because there's plenty more videos like this. I go a lot more in depth with some of these parts and components and boilers and whatnot. We also have plenty of other videos. We're building a home, we do a lot of projects for construction work and site work, so a lot of cool videos on our channel. Go ahead, check it out, and like I said, give this one a thumbs up, and we'll see you guys on the next one.